Welcome, folks. Today we're going to be talking about scientific notation and understanding how to put numbers in scientific notation, a skill that's very important in chemistry. So in order to convert a number into scientific notation, there's a number of rules that you have to know. I'm going to go down them in order. First one, move the decimal point so only one non-zero digit is to the left of the decimal point. This is very critical because you can't have a number that is greater than 10 to the left of the decimal point and have it be in valid scientific notation. Next, if you move the decimal point to the left, the power of 10 will be positive. And we're going to go over a couple of examples of that very shortly. If you move the decimal point to the right, the power of 10 will be negative. So, moving to the left, power of 10 is positive. Moving to the right, the power of 10 is negative. So here's a couple of examples. We'll start out with the number 3600. Now we want to change this number, 3600, into scientific notation. And we can imagine that our decimal point is right about here. And so we're going to move the decimal point over 1, 2, 3 times, indicating a positive power of 3 here. Notice that the non-zero digits are listed right here, 3.6 times 10 to the third power. Next, we've got another example. That is 0.0000752. And we're going to put this in scientific notation. How many times do we have to move this decimal place over? 1, 2, 3, 4, 5 times. Since we're moving it to the right, this decimal place, it indicates a negative power here. So we take our non-zero digits, 7, 5, and 2, 7.52, because that's where we move the decimal place to, multiplied by 10 to the negative fifth power. So here are a couple of examples we can work out. If we had this very large number, 5,732,873.912, we could use the same process listed above to convert it into scientific notation. We would start off by figuring how many times we have to move this decimal place over so that this number, the number represented, will not be greater than 10. 1, 2, 3, 4, 5, 6. 6 times. That means our power of 10 will be the 6 to the 6th power. If I write this out, because these are all non-zero digits, 5.732873.912 times 10 to the 6th power. Next, another example. 0.12404. How are we going to get that into scientific notation? Well, this is a simple one. We want a number that is not greater than 10. We don't want it less than 1. And therefore, we're going to move the decimal place over just one time. So this becomes 1.2404 times 10 to the negative first. Notice that we move the decimal point to the right, and therefore we have a negative exponent. All right, thanks for your time.